Right, do now number 6. Here are some questions for you. You will need a calculator for this, so you might need to go online and get a online calculator if you haven't got a proper one with you, or you could use your phone. If you turn it on sideways, you get a scientific calculator with most of them. Usually you have to have it unlocked to do that. Okay, so you've got 5 minutes. Start. Oh yes, and have a go at everything. Don't ignore it. Just get on and have a go. All right. So you've got 5 minutes starting now. Let's get rid of the clock. Right, these are Pythagoras questions. We've got a right angle triangle. I'm trying to find missing sides on each one. So it's not trigonometry, it's not SOHCAHTOA. It's Pythagoras. Now, if you remember with Pythagoras, if you take the two short sides and you square them, so 6 squared and whatever that is squared, add it together, it's the same as taking that long side and squaring that. I use h for hypotenuse. Now, the long side on this one is that. Now, if I call, say, this side x, 6 and the length of x are the two short sides. So if I did x squared plus 6 squared, it will be the same as 20 squared. All right, square the two short sides and add them, same as the long side squared. Now, I want to find out what x is. Because I'm finding a short side, I'm actually going to subtract. Do the long side squared, take away the other side squared, and what will be left will be x squared, right? Now, if I do that, 20 squared, take away 6 squared, put it in my calculator, I get 364. Now, the length of my side is clearly not 364. I need to square root it. So I square root 364. And I get the answer when I press SD to 1 decimal place of 19.1 centimeters. Okay, so let's try the next one. All of these are Pythagoras. They've all got right angled triangles, and we're all trying to find the lengths that are missing. Now, if you look at this triangle, yeah, it's a ladder against the wall. This question seems to come up a lot. It's all about how far up the wall it is, which is this side. Let's call it Y. Let's find out, what that side is. Now, if those are y and 1.5 are the two short sides. So if I do y squared, if I added that to 1.5 squared, it would equal 4 squared because of Pythagoras. Right? Now let's take away the 1.5 squared. So I'm doing the long side squared, take away one of the short side squared, that will leave the other short side squared. Use your calculator. Don't need to do it in your head. 4 squared, take away 1.5 squared is 13.75. I need to square root that to get to my answer. That's not an r, it's a square root. So I square root it, and I get the answer of 3.7 to 1 decimal place. It didn't say what to round it to, so I chose that. And it sounds like a reasonable answer. It's long. It's shorter than the long side. It's it's kind of reasonable. Just have always a little think. Does it sound reasonable? Yeah. And it should always be shorter than the long side too. Again, I've got another side here which I'm trying to find. Let's call it Z. That is a short side, isn't it? Because look, the right angle points to the hypotenuse, which means again I've got whatever Z is. If I square it and I add it to 10 squared, the other short side, it will equal the long side squared. That's Pythagoras. So let's take away 10 squared. So I've got my long side squared, take away one short side squared, and I get the answer of 14 squared, take away 10 squared is 96. And I don't want z squared though, so you always square root in the end to find out what the answer is. And the square root of 96 is 9.8 to 1 decimal place. And this is in centimetres as well. Oh, I put centimetres down for this one. It's metres for the ladder, isn't it? Otherwise it's like a ladder for gerbils. Right. Yeah. Brilliant. Off you go. I hope you got those right. If not, maybe just look up Pythagoras a little bit and choose some extra questions on Dr. Frost to practice with. Bye-bye.